three-step process, okay? IB. IB is this circuit here. And that circuit is voltage over resistance, V over R. The voltage happens to be VBB minus VBE divided by RB. That's the current in the circuit on the left. I've got VBB, which is my supply voltage. VBE happens to be this voltage here from the emitter to the base, which is always 0.7 because it's a PN junction there. So VBB in my case is given to be 4 volts. VBE I indicated as 0.7. At this point, I do not put a negative value, okay? If I put a negative value, all my answers will be wrong. So first, treat all your calculations like an NPN, and then just change the value after you do the calculations. 100K. How much? 33 microamps. So what do I do after the dotted line? Negative 33 microamps. What does that mean? It's just flowing in the opposite direction. Now I find IC. To find IC, I use the HFE value. I use this equation here to find IC. I know the value of beta. I now calculated the value of IB. So IC is HFE times IB. So it's 125 times bigger than IB. How much? 4.125 milliamps. Okay, so after the dotted line, negative 4.125 milliamps, which is simply saying that the direction of the current is up instead of down. There's an IE in there. Let's calculate IE. This is not critical, but we'll just do it because we're learning about transistors. What is IE? It is the sum of IB and IC. In a transistor circuit, IE is always the sum of IB and IC. So that's 333 microamps plus 4.125 milliamps. How much? 4.158 milliamps. Not a big difference between IC and IE. Okay? One is 4.13, the other one is 4.16. So about a 0.03 difference. Negative 4.158 milliamps, which is saying that the current is in the opposite direction than in an NPN circuit. Make sense? Good. So now let's calculate VCE. VCE. VCE is this voltage here, from the collector to the emitter. Okay? And I just look at the circuit on the right. And so VCE happens to be VCC minus the total voltage minus the voltage drop at RC is equal to the voltage drop at the collector to emitter. So it's VCC minus the voltage drop at the resistor is I times R. So IC times RC. That's VCE. So that's going to be 9 volts minus IC is the one I calculated, 4.125. Do not use the negative one for calculation purpose. Just stick with the positive values. Times RC. 1K? How much? Milli and kilo cancel. 5 point something. What do you get? 4.875. And so after the dotted line, how much? Negative 4.875. Okay? That's the value I show on the graph. So I take that value of 4.875, I come over here, there's my VCE, maximum is -9, halfway is 4.5, so where's negative 4.875? Just on the other side of it, right about here. And from there, you drop and hit the Q point, or rather hit the load line, come across. At this point, write down Q. Q is the operating point of the transistor. So 4.875 across here, how much? Tell me. IC. What do you get for IC? 4.125.